Project Binky in colour. Starring Nick Blackhurst. Also starring Richard Brunning. And Rex Hamilton as Abraham Lincoln. Tonight's episode, a box for all seasons. Coming up in episode 16, Nick buys himself a present. I test out my prototype cloaking device.
Yeah, that seems to work.
And we try out a new T-Boy.
There you go, boys. Oh, thanks. Thanks, mate. That's great.
At the end of the previous episode, we'd run the brake lines, made a reservoir, and plumbed it all in. I wonder what Nick's got planned for us now.
If you very much enjoyed all that plumbing, then you're in for a bit of a treat, because next on our list of things to do is some more plumbing. If you didn't enjoy it, well, tough. It's the next thing on the job list.
It's important to keep a list of achievable goals.
But don't switch off yet. There'll be grinding, there'll be welding, there'll be hot oil and enormous pressures. There's an almost certain chance of death. Yes, it's time to sort the power steering. Well, okay, maybe it's not going to be that exciting, but, you know, it's power steering, what you're going to do. So, first part of the job is to make the high-pressure pipe from the pump to the rack. Only we don't have the equipment to make a high-pressure hydraulic line, so what we're actually going to be doing is making a pattern, and then we can take it somewhere and get a proper pipe made.
We're going to start with this lot salvaged from the Celica and other assorted cars we've got kicking around the workshop, along with some straight tube. After unstraightening the tube somewhat, the end with the flare and the fitting is welded on. This is now screwed onto the feed side of the steering rack. It's quite tight against the bulkhead, but we think it's okay. Before we carry on along the bulkhead, we need a flexible joint because the rack is rubber mounted, which means a swaged end, and that's the bit we can't do. So for the purposes of making the pattern, we're going to try and recycle this one, using a grinder. It's the go-to tool for almost any occasion. Then we can cut the other end of the pipe to the length we want. And now we've bent the straight tube around the profile of the rack mount on the bulkhead. And now we can reattach the recycled swaged end to the flexi pipe. The MIG welder takes care of tacking it back together. So here's the second part of the high pressure line. Now it's just got to be connected to the first part we made earlier. For this, we'll break out a piece of machinery that some say swings a bit AC/DC, and that its handle can be ribbed for extra sensation. All we know is, it's called the TIG. There it is, looking pretty good. And even though this is just a pattern, we've cleaned back the welds and tidied it up. Fitted to the car, it looks like this. And now we've added a short straight bit on the end. That's as far as we can go right now before we've got the pump mounted, so we've got something to aim at. And for that, the engine has to go back in. And the cross member, and the radiators.
If you've got a good memory, then you already know that we had to remove the original Celica power steering pump and bracket from the back of the engine so we could get the rack to fit. Now we could relocate and reuse that original pump, but we've got a bit of an issue coming up with the rotating ancillaries as it is, but we'll get to that in due course. For the power steering, we've chosen to circumvent all of those problems and switch from a belt-driven pump to an electro-hydraulic pump. And of course we're choosing to ignore that that doesn't actually solve anything, it just gives us a different set of problems.
Our weapon of choice for the power steering pump is this unit from the first and second generation Mercedes A-Class.
I chose it out of thousands. I didn't like the others, they were all too flat. Now, it's a fairly simple device. You put oil in the top here, you put 12 volts in here, and power steering comes out here. And it's its tall, thin shape that means we can use it because it needs to live down here. So we just need to make a bracket to mount it now, but I've been thinking about making a bit more room for the exhaust for quite a while, and this seems like the perfect opportunity to do it.
While Nick whips his grinder out and does the dirty on the chassis legs, I'm gonna get the funk out. Well, that's all fine and dandy, but I can't see what it's got to do with the exhaust.
Well, that's because I haven't finished yet. I'm still chasing millimetres. And if we edit the front end back on for a second, you can see that there's at least 25 of the buggers loitering between the front crossmember and the front panel and its hinge.
So to extract these 25mm, we've got to completely remake the front crossmember. It was enough of a ball ache the first time, but as with everything on this build, millimetres matter, so it's got to be done. The hole was drilled undersize, and now we're using the die grinder with the angry end on it to take it out to size. The sanding wheel just cleans it up to finish, and the grinder parts it off in the middle to give us two identical brackets. The grinder also cuts out the box section profile so we can weld them onto the main rail later on. These holes are for the addition of some captive nuts inside the box section, and now here they are being tigged into place. This tube is going to make up part of the flip front's hinge mechanism, and in the absence of any engineer's blue, we're using a felt pen to help mark it up. The second tube is only there to make sure the marking is done exactly at the top by keeping the blade horizontal. This hole is going to be the end of a slot cut into the tube, and the accuracy here is really important for the smooth removal of the front end. And what could be more accurate than a big tart from Shropshire, a 4.5-inch angle grinder and a slitting disc? With the slots cut out, we move on to welding the bottom section with the captive nuts inside to the main crossmember. Remember those little U-shaped brackets from 1 minute ago? Well, here they are being welded into position. These are going to hold the hinge tube for the flip front. And here is that hinge tube being carefully clamped into position before being welded to the brackets. We don't need the whole tube, so Nick's hacking the middle part of it out with the grinder. To attach the crossmember to the chassis rails, we need a couple of suitable upstands. After marking the shape out on the steel, they're cut out, drilled and bent up before getting thoroughly welded to the main crossmember. For some decent strength, here Nick's welding in some gussets on each side of the upstands. This box section with a hole being drilled in it will be the bottom location for one of the radiators. After being split into two identical pieces, they get welded onto the crossmember. The forward radiator support is mildly more complicated, but copious use of the pillar drill, grinder and welder see the brackets on and the new crossmember complete.
One finished for now, redesigned front lower crossmember stroke radiator support. There's lovely.
It certainly is lovely, but it won't actually fit, because we've got to tweak this downstand from this to this. Well, now you can bolt it on. With the new crossmember sorted, you can see the scalloped chassis legs give us room to mount the power steering pump, and the same on the other side means we can now put the exhaust downpipe inside of the chassis leg. Here's a shot of the old crossmember in position, and now the new one with that extra 25mm of room in front of the engine and box.
Well, that was a lot of effort for an extra inch.
Indeed it was, but that was considerably more successful than those other methods you've tried to gain an extra inch or so.
You may have noticed the complete lack of any electric flip front mechanism. Well, truthfully, it was way too complicated, so it had to go. If we needed to do it again, we'd probably have to re-engineer the whole thing with some sort of electric linear actuator, and truthfully, ain't nobody got time for that.
Honestly, I blame you lot for this. Yes, we went there. Why do you think this episode was so long in the making? It's mainly down to this collection of parts. Completely reimagined, redesigned, re-engineered and remade. The head scratching, tea drinking, working out, trial and error, huge frustration, panic and finally relief at making it work was almost worth it. The electric linear actuator is now mounted inside the near side front wheel well and contains limit switches on both ends of the travel. This allowed us to hook it up to a 2-button remote key fob to activate the mechanism. Even by our standards, it's a hell of a thing. If we'd filmed making all this lot, we'd still be doing it now. You wouldn't believe how long this took, but more on that in a minute. It's amazing what you can make with 15 quid's worth of eBay electronics and a ton of time and effort. Right, can we just get on with mounting this pump? But for that, we need to open the flip frame. So all we need to do to mount the pump is make a simple L-shaped bracket with a hole at the bottom for this peg to go into and a slot for this bolt to do up on. It really doesn't need to be any more complicated than that.
A lot of people ask us, how come this is all taking so long? And it's a perfectly valid question, because it's one I ask myself all the time. Now, it's probably fair to say we vastly underestimated the amount of time it takes to film what's going on and then produce something interesting and watchable with it. But fundamentally, it's the fact that making one-off stuff takes time. How much time? Let's find out. Yep, just this once for the inquiring minds out there, my own included, we're going to put a clock on the next bit of fabrication. As Rich says, it's a relatively simple bracket to hold a power steering pump, so it shouldn't take that long. We've already got our piece of steel to work with, and we're not worrying about the hour or so that we spent staring at it trying to work out what to make. It does, however, mean that you've got to sit through another fabrication montage. Sorry about that.
Here we go then.
Right, kettle on. Yep, 7 3/4 hours. What's that, about 3 football fields for you Americans? Or to put it another way, about half of the average time we get up here to play at the weekend. So, best hope it fits now, eh?
I never had any doubt. It's lovely. And by the way, that 7 3/4 hours was actual work time. We stopped the clock every time we had a brew, had some lunch, or went for a waz. I know what you're thinking. That's a ludicrous amount of time to spend on a bracket. But it is what it is, and on this build, everything we do takes an inordinately long time because it's all made from scratch. Anyway, with the pump installed, we can finish off the fluid lines. Now we've got something to aim at. The high pressure line originates at this port, and we're going to run along the top of the chassis leg and around the front of the pump to get to it.
I wouldn't call it future-proofing necessarily, but here we've designed in a bit less future arse. If we need to drop the engine and box out, we've already got to remove this front cross member and these chassis rail ends, and now obviously this power steering pump is in the way. Well, routing the pipe this way means that we don't actually need to disconnect everything and drain the system down. We've got enough slack to simply pick up the power steering pump and bracket and move it to the outside of this chassis rail where it's completely out of the way. So now all we need is a return line. It runs a lot less pressure than the feed line, so we can actually make the finished article in-house. Don't forget, this high pressure line is only a pattern. We've got to take this off and go and get a proper one made. Thankfully it is only the one, because multiple hose gets real expensive.
The return line starts with this bit of black hose at the back of the pump and goes through this bit of unstraightened tube, made out of one piece I might add, and there's a barb on the ends to locate the flexi hose nicely. That fits in behind the high pressure line, and this is the last little tricky bit that bolts onto the rack. Something like this. With it all fitted together, all we need now is something to hold it all in place. These little nylon clamps, much like we made for the brake and fuel lines, will do the trick. If we bang on the head again for a minute, you can see there's plenty of room under the inlet manifold, so barring the addition of the custom high pressure hose, we can call that done. So now with the power steering sorted, we can move on to 4 letters that strike fear into the hearts of custom car builders everywhere. HVAC.
Yeah, even with something as simple as, say, an engine swap, sometimes the minute you move away from the OEM setup, hooking a heater up becomes such a ball ache that people don't bother. Well, that's not an option for us, so let's get into it. This is the heater out of our Mini. All of it. And during the Mini's long production run, these things went from, well, shite to not really any better. Here's why. Hot water is circulated from the engine through these small bore pipes here into an undersized matrix in here. Air is drawn in through here and then blown through that matrix by this little anemic fan and then directed out by these undersized ducts here. You've got 2 fan speeds in 1980, off and might as well be, and I'm not going to mention the flaps because you lot will just make rude jokes. I'll tell you what, let's pull this box apart and do some comparisons with bits that work.
Here we have the Mini's matrix up against a modern version, and you can see the fluid pipe bores are much bigger these days. The fan can waft far more air than the feeble Mini version, and just for comparison, here's the entire Mini heater box against just the fan cowl from an MG ZR.
Now to be fair, they did marginally improve all of these areas for the last few years of Mini production with the redesigned heater box. We don't have one, and even if we did, we couldn't fit it because someone has taken up all of the space it lived in with a bulkhead and a tunnel. So here's the challenge. What we need to do is make an entire heater system that uses modernish sized components and fit it into less space than we had for the original Mini heater. And of course, I really would like to get some AC in there as well. So I think something is going to have to give.
Now somehow we've got to work out how to fit this lot inside our Mini. I'm not sure this is possible. So a long story short, we started off with this, went through this, had a brew and drew this, cut this out, played with an awful lot of this, and ended up with this. Yes, we built a fully functional working heater box out of cardboard. This is the mother and father of all CAD templates. It fits behind the dash rail and against the bulkhead here, and as you can see there is just enough depth available for it.
So what I had to give? Well, the glove box and a little bit of passenger foot space, which I think will do. What won't do is cardboard.
Well, I've no doubt that lightweight cardboard laminate heater boxes are indeed the future. We're going to make this one out of aluminium, because it's shinier. Making stuff out of alloy is much the same process as making it out of steel, only the welding is more difficult. After marking it out, cutting the main shape out with the grinder, using a very wobbly hole saw, hand bending the return shape and TIG welding it all together, we can use the world's most dangerous saw to cut out that bit that will house the fan speed resistor. Once that's complete and filed back, we end up with nearly half an aluminium heater box.
Having nearly half a heater box implies there's another half to come, which indeed there is. And to give us a chance of keeping them together, I'm going to weld some of this alley strip all the way around the outside to act as a locator. Having that double lip should also help keep the wind in.
It's for precisely such an occasion as this that we keep a very large collection of clamps and mole grips around. After bending the alley round the outer profile by hand, the lip is welded on and it looks like this now that's complete. The next stage is to make the strip that will house the fan speed resistor. It's a tricky little piece with 3 different shapes that need to be cut out of the strip, but with those done, the test fit seems to work beautifully. We need 2 more bits to attach to either end of that latest strip to carry on the profile of the heater box. Some careful bending and a bit of TIG welding later, and now it's really beginning to take shape.
I think the next step is to work out a way to fix these 2 halves together.
To do that, we're making a collection of little aluminium tags, drilled and tapped and then parted off on the bandsaw. Yeah, we do have one. Anyway, these tags are then bolted to the main box and then TIGged into place. Sorted. The reason for all these tags is for the ability to disassemble it, so we can fit all the stuff inside the box, such as the heater and aircon matrices, the fan and the clever cylinder that controls the airflow direction. With that complete, we can move on to making the top cover. We're going to do the top cover in 2 pieces essentially, as there's some contouring that makes it really difficult to make it out of one piece. The bender adds one of those contours with multiple straight bends over a very short distance. That part is now welded to the main box. We've whipped up a nice little shaft to keep the 2 covers perfectly aligned along the centre line of what will be the air direction mechanism. That lower part of the cover now gets TIGged onto the box. That, I have to say, is not looking too shabby. This is the cover that will house the fan speed resistor, and it goes here on top of the heater box above those openings. Much like this in the end. Lovely. The next job is to recreate this opening in the heater box to house the blower motor. First we mark out the bolt circle diameter for the location pins, and then the outer hole diameter, and finally the centres for the location pins.
Who remembers this from school then?
I do remember you stabbing me in the arm with a compass, more than once. The 3 holes for the fixings are drilled, and then we turn up the pins on the lathe, before TIGging them onto the heater box. The main hole is very roughly cut out with the Fate Worse Than Death wheel, before being hand finished with the die grinder. The fit, as you can see, is bob on.
That's the easy bit done. Now we've got to make the bit that directs the air.
Cut out 2 squares in the usual fashion, and after being roughly roundificated and punctured, we're going to further assault them by squeezing them in the press. After being reflattened, the 2 pieces get turned down to size together on the lathe. To make the outer circumference, we mark out the right length on another strip of aluminium, and then bend it round a suitable round thing. In this case, a pair of cam pulleys bolted together works a treat. The final closing before being welded up is achieved with the use of a couple of Jubilee clips and an impact gun. Once welded together, what we end up with is a very small biscuit barrel we can't get into. After smoothing it down on the belt sander, we've got to cut some holes in it to let the air pass through. Break out the grinder again, Nick. With the air ducts cut out, the next job is to weld an axle through the centre of the cylinder. That axle sits on this little peg here, which is attached from the back. Next up, we need an outer skin that gets welded to the main heater box. The process is much the same as the inner cylinder, i.e. bend it round a pair of pulleys. And there it is, tigged into place. Next, this horseshoe bit needs welding on. Something kind of like that is great. Then we cut out the holes where the air distribution hoses fit on. The hoses are going to fit over these aluminium tubes we're chopping off with the rage saw. And of course, after cleaning them up, they get welded to the main heater box. I think he's finally getting the hang of the TIG now. With the tubes on, the heater box is pretty much finished, isn't it?
Well, it's nearly finished. I mean, we've just got to put a small outlet at the top, a drain at the bottom, tidy all the welds up a bit, sort the matrix out, find out a way of fitting it in the car, and then plumb it. But sadly, we're pretty much out of time, so that's going to have to wait till the next episode.
Yes, you're going to have to wait until next time to see us mount that lovely box. Until then, thank you very much for watching. Be sure to tune in next time for another exciting episode from the files of Project Binky.
Flip front goes up. Flip front goes down. It's just genius.